Okay, so we have discussed the Thevenin's theorem. We'll be doing more numericals on it later. Mm, is my voice audible to everyone? Is it breaking? Okay, then. So we'll continue. If you are facing any issues with use of Microsoft Team, अगर आपको Microsoft Team यूज नहीं करना है, कोई और प्लेटफॉर्म यूज करना है, तो आप मुझे बता सकते हो. So we'll now start with the Norton's theorem. We have done the Thevenin's theorem. उस पे हम और numericals कर लेंगे. We'll be first taking up the Norton's theorem. Norton's theorem is actually analogous to the Thevenin's theorem. It's almost the same theorem, just in a different representation. So what does Norton's theorem state is that in any electrical circuit network can be represented by an equivalent circuit. So any electrical circuit network can be replaced by, now instead of having a voltage source here, we'll be having a current source. That current source will be known as the Norton's current source, and it will be in parallel with the Norton's resistance, and then be parallel with the load. Fine. So the Thevenin's equivalent circuit was something was like this. The Norton's equivalent circuit is like this. You have the Norton's current in parallel with the Norton's resistance, and you have the load resistance at your usual point. Fine. So this is your Norton's equivalent circuit now. So just like uh, Thevenin's equivalent circuit, Norton's equivalent circuit will find the same use. You can replace any circuit by a Norton's equivalent circuit. So जहाँ पे आपको लगे, wherever you can find that uh, solving the circuit will be much easier using a current source, or you are much more uh, you uh, your requirements of current, your requirements of knowledge of current is much easier to find using a Norton's equivalent circuit. Simply by using a current divider law, you can find out the value of current across this load resistance. So there you can use the Norton's equivalent circuit. It is similar to the Thevenin's equivalent circuit. If we simply use the source transformation, once we do the source transformation of this particular circuit, the Norton's equivalent circuit, you will be having a voltage source in series with a resistance, and then if we do the source transformation of the Norton's equivalent circuit, we'll convert this current source into a voltage source. So this voltage source will be having a value of Rn into In, while as this current here, this resistance here is Rn. Now this resistance will be in series with this voltage source, and then you have your normal load voltage, variable load voltage in series with this resistance. So this becomes equivalent to this. So you can look at the two circuits and say that your Thevenin's resistance is nothing but the Norton's resistance, and your Thevenin's voltage is nothing but Rn multiplied by In. Fine. So a Norton's equivalent circuit is a representation of an electrical circuit network using a current source in parallel with Norton's resistance, and then that having your variable load connected to that particular network. You can convert that Norton's equivalent circuit to a Thevenin's equivalent circuit by simply using the source transformation. You can convert your current source to a voltage source. Once you convert the current source to a voltage source, your new voltage will be equal to Rn multiplied by In, whereas this Rn now will be in series with this voltage source. So looking at figure 1, this is figure 2. From figure 1 and figure 3, you can see that RTH is nothing but Rn and VTH is nothing but Rn into In. Or in other words, you can also say In is equal to VTH divided by Rn. So अगर आपके पास, if you have any circuit, you find out its Thevenin's equivalent, then you can actually use the source transformation to find out its Norton's equivalent circuit. So that will be one way of finding out the Norton's equivalent circuit. So one way of finding the Norton's equivalent circuit is to find Norton's equivalent circuit, find the Thevenin circuit, and then simply using source transformation convert the voltage source to the current source. So ये जो आपका circuit है, this is your Thevenin's equivalent circuit. You can also convert your VTH into a current source because VTH is in series with some resistance RTH. So this can be converted to a current source in parallel with RTH. Or now you have these equations, you know these equations. You can simply, once you have the Thevenin's equivalent circuit, you can simply find out Rn, and you can then simply find out the value of In, place those values in the Norton's equivalent circuit, and find out the Norton's equivalent circuit of this particular network. So this will be one way of finding out the Norton's equivalent circuit from the Thevenin's equivalent circuit. Or if you want to directly find out the Norton's equivalent circuit, uh, the procedure is almost similar. Uh, you have to find Rn, that is the Norton's resistance now, in a similar manner to RTH. Like we find RTH, that is open your load terminal, turn off all the independent sources, voltage sources and current sources, and then we found out the equivalent resistance across that open circuited end. So similarly, you can find out Rn in the same way as you find RTH. There is no difference there. Then to find In, that is the uh, instead now we do not need to find VTH here. We do not need to find out Thevenin's voltage. We need to find out the Norton's current here. To find In, short circuit the load and find the short circuit current. That short circuit current ISC will be equal to In. That means if, say, for example, you had a circuit like this, if this was your variable load voltage, what you have to do is you have to find out first of all Rn, You have to open this. You have to turn off the voltage source. Turning off voltage source means shorting this. Find out the equivalent resistance at this particular point. That equivalent resistance will be your Norton's Norton's equivalent Norton's resistance Rn. Fine. That is one. Secondly, what you have to do is you had your voltage source here, you had your variable load connected at this point. What you have to do in the second step is to now find out IN. What you have to do is you have to replace this load resistance by a short circuit now, not by an open circuit. Whatever is the current that is flowing through here, that is the short circuit current, that will be your Norton's current IN. So this is how you find out the Norton's equivalent circuit. The use of this Norton's equivalent circuit will be somewhere similar to that of Thevenin's equivalent circuit, but wherein you want to design your system for a constant current source. There, the use of Norton's equivalent circuit is much more. There, Norton's equivalent circuit will be much more needed as compared to a Thevenin's equivalent circuit. So let us take an example to find out a Norton's equivalent circuit. You have to find the Norton's equivalent circuit of this. That means you have to convert this into this form: IN RN AB. Fine. So first of all, find out Rn. To find out Rn, we have to turn off all the independent sources. Turning off independent sources means current source open हो जाएगा, voltage source short हो जाएगा. That means ये वाला end आपका open है. You have a 4 ohm resistance here. There is 8 ohms here. There is 5 ohms here. You have to look into this circuit and find out this equivalent resistance. So you can now neglect this portion of the circuit. So this is simply 8 and 4 are in series. They are in parallel with the 5 ohm resistance. So 12 parallel 5. mm, So Rn is 12 parallel 5, 60 by 17 ohms. So to find out In, keep the sources on. 2 ampere source here. There is a 4 ohm resistance here. 12 volt source here. 8 ohms. 5 ohms. Now to find out In, what you have to do is you have to actually short this particular end AB. Now if you are short circuiting this end, that means all of the current will be flowing from there and none of the current will be flowing from this 5 ohm resistance. So you can actually consider this 5 ohm resistance. You can actually ignore this 5 ohm resistance because of the presence of the short circuit at the terminal ends. Now you have this circuit, you have to find out the value of current actually that is flowing from here. So if you use mesh analysis I1, I2 from loop 1, you can directly say I1 is equal to 2 amperes, and using KVL in loop 2, 12 volts uh, is equal to 4I2 minus 4I1. 4I1 is 2 amperes plus 8I2. So this is I2 actually. Yeah. So this means what will be the value of I2 from here? 12I2 is equal to 20 by 12, 5 by 3 amperes. So this I2 is your short current through the short circuited end. That will be now your IN. So you can redraw the circuit for this particular case. This will be 5 by 3 amperes. This Rn will be at 60 by 17 ohms, and this here you will have any load connected at this particular point AB. Yes. Yes. Uh, 12 and you can do the source transformation. Do the source transformation where you feel there is a necessity and it will ease your calculation. If you do the source transformation here, 12 volts or 4 ohms, they are in series. उससे आपको उतनी ज़्यादा calculations में there will not be that much of ease in calculation. In this loop, KVL from loop 1, I1 is equal to 2 amperes directly. Then you have this particular loop number 2. Apply the KVL in this equation. ये आपका KVL equation है. 12 volts is equal to 4I2. और यहाँ से जो करंट है 4I1 है, that means 4 into 2 plus 8I2. So ये equation मैंने solve की. This is 12I2 is equal to 20. So I2 is equal to 20 by 12. वो 5 by 3 amperes है. KVL in loop 2 ये equation है. ये equation आपको solve करनी है to get the value of I2. क्या I2 कैसे डिसाइड करें, क्या मतलब? हाँ, क्योंकि I2 यहाँ से करंट फ्लो हो रही है ना, इस ब्रांच में करंट I2 फ्लो हो रही है. शॉर्ट सर्किटेड एंड में जो करंट फ्लो हो रही है दैट्स I2. यस. So this is one way of doing it. Another way is find out the Thevenin equivalent circuit and then do the source transformation to find out the Norton equivalent circuit. You can do it in that manner as well. Again, we have to find out the Norton's equivalent circuit of this particular circuit. First of all, find out Rn. turn off all the independent sources. That means voltage source को short and current source को open करना है. So this is shorted here, 3 ohms, this is 3 ohms, this is 6 ohms. A and B, 3, 3, 6. यहाँ पे जो करंट सोर्स था वो ओपन हो गया. 3, 3, 6 और 6 पैरेलल में. R equivalent is Rn is 3 ohms. 3 and 3 they are in series, 6 ohms, 6 ohms and 6 ohms, then they are in parallel. 6 into 6 divided by 6 plus 6. 36 divided by 12, that is 3 ohms. To find out In, this is your 15 volt source here. 3 ohm current, 3 ohm resistance, 4 ampere current source, 3 ohm, 6 ohms. AB इस एंड को आपको शॉर्ट करना है. अगेन once you short this end, since this particular resistance is in parallel with the short circuit end, again it will be open circuited. ठीक है, ये AB हो गया, ये आपका I1 हो गया, ये आपका I2 हो गया. So you have to actually find out the current that is flowing from this path, that is I2. You can use, since there is a current source present in between two meshes, this you can take the super mesh here. सुपर मैश की जब आप KVL लगाओगे to the super mesh, KVL to super mesh, 15 volts is equal to 3I1 plus 3I2. Fine, this is one equation. Also from the current source, 4 ampere current source, you can directly write I2 minus I1 is equal to 4, which implies I1 is equal to I2 minus 4. Substitute this here. 15 is equal to 3I2 minus 4 plus 3I2, which implies 15 27 is equal to 6. क्या है आपका I2? 27 divided by 6 amperes. We are actually concerned with only finding out I2. I1 हमें निकालने की जरूरत नहीं है. I2 therefore is 27 by 6 amperes, or you can say In here is I2 is 27 by 6 or 9 by 2 amperes. That's 4.5 amperes. Then there is the case of dependent source. जैसे हमने Thevenins में किया, you have to follow the same rule here also. 6 ohms, you have a 10 ampere current source here. You have a dependent voltage source plus minus 2Vx, 2 ohms, A, B. Vx is the voltage across this 2 ohm resistance. You have to find out the Norton's equivalent of this. First of all, you have to find out Rn. Rn वैसे ही निकालना है जैसे Rth आपने निकाला for the Thevenin equivalent circuit with a dependent voltage source. That means you have a 6 ohm resistance here. 10 ampere volt current source वो open हो जाएगा. डिपेंडेंट वोल्टेज सोर्स ऐसे ही रहेगा, प्लस माइनस 2Vx. This is 2 ohms here. Across terminals A, B, what you have to do is you have to either use a voltage source or you can use a current source. Say if I take a voltage source here, का value मैं कुछ भी रख सकता हूँ. I can even keep it this 10 volts. मैंने 10 volts लगाया यहाँ पे. So what I want to find out is the current that's actually flowing through this path, to find out actually the net resistance offered by this circuit. So that will be Rn. So I'm applying a 10 volt voltage source here. If I apply a 10 volt voltage source, you have 2 kV, you have two meshes here. This is loop number 1. Let current here be small I1. This is loop number 2. Let current here be I2. By applying K, एक चीज यहाँ पे देख लो, ये जो वोल्टेज है across this Vx, it is simply whatever voltage source I am applying here, that means Vx is directly equal to 10 volts. So by applying KVL to loop 1, 6I1 plus 2Vx, fine, plus 2 into, I will not write 2 into I1 minus I2. इस रेजिस्टेंस के अक्रॉस जो वोल्टेज है that is Vx, that is 10 volts, plus Vx is equal to 0, fine. So I can write 6I1 plus 3Vx, where Vx is 10, is equal to 0, which implies 6I1 is equal to minus 30, I1 is equal to minus 30 by 6, that is minus 5 amperes. तो ये तो करंट मेरी हो गई यहाँ से. I2 का वैल्यू क्या होगा, because I'm more concerned with I2. Voltage across the 2 ohm, voltage across this is 10 volts. 2 into in the direction of I1 minus I2 is equal to 10. Yes, 2I1 minus I2 is equal to 10. I1 I have already found out, it is minus 5 amperes. 2 into minus 5 minus I2 is equal to 10, minus I2 minus 10 plus ये 20 हो गया. I2 is equal to minus 20.
So minus 10. Sir, minus 10.
ओके, ये 2 यहाँ पे भूल गया मुझे. दिस ये 2 इसके साथ भी मल्टीप्लाई है. 2I2, so ये minus 10 amperes आएगा. If I2 is minus 10, that means I is minus of minus, I is equal to minus I2, which is equal to 10 amperes. Fine. Now my I is 10 amperes here. The original voltage that I have applied is 10 volts. So Rn therefore will be equal to voltage that I have applied, that is 10 volts, divided by the current I, that's also actually 10 amperes. I am getting 1 ohm.
Sir, I is equal to minus I2
I2 अगर आप देखोगे, I2 मैंने ऐसे दिखाई है करंट. I2 मैंने ऐसे दिखाई है, that means I2 इस डायरेक्शन में है और I जो है इस डायरेक्शन में है, तो I2 माइनस I के बराबर है. This is Rn. Now you have to find out In. To find out In, original circuit, this is your 6 ohm resistance, 10 ampere current source, 6, 10, plus minus 2Vx. This is 2 ohms. This is your terminal AB. Fine. This is your terminal AB. To find out Rn, what you have to do is you have to short this end. To find out In, you have to short this end. Once you short this end, since 2 ohm resistance uh, is in parallel with a shorted resistance, so that means यहाँ से कोई current flow नहीं होगी, so you can ignore this resistance here. So this is effectively your circuit now. So now you have to find out the value of current here. मैं यहाँ पे ये resistance दिखा रहा हूँ just for one reason. यहाँ पे जो voltage थी इस resistance के across, that was Vx. Since no current is flowing through 2 ohm resistance, that means voltage across this Vx will also be equal to 0. So that means this voltage will also be now equal to 0. So what will AB, therefore what will be the current I flowing in this resistance?
10 ampere.
ठीक है, तो यहाँ से कोई भी resistance offer नहीं हो रही है, so all of the current will be flowing in this path. So IN you can directly write now is equal to 10 amperes. Is this clear?
Yes, sir.
Fine. There was a 2 ohm resistance here जिसके across voltage Vx थी, but since no current is flowing from that 2 ohm resistance because of having a shorted circuit and in parallel with it, that means Vx is 0. If Vx is 0, that means this dependent voltage source is also offering 0 voltage. Since there is no resistance in this particular mesh, no resistance is being offered in this particular mesh, all of the current will be flowing through that path only. So IN will be equal to 10 amperes directly from the current source that is provided here. No current will be again flowing through the 6 ohm resistance path. Okay, ये आपका क्वेश्चन है. Okay, so this is your question. You can try this. Find the Thevenins. If you have the Thevenin circuit, you can find out the Norton's equivalent circuit as well. Find the Thevenin's equivalent circuit as seen from terminals AB and B BC. ठीक है. You have to actually find out two Thevenin equivalent circuit. You have to find out the first Thevenin equivalent circuit if you look into this particular end only. That means only through AB. ठीक है. उस टाइम पे जो BC circuit है, that will be part of the Thevenin equivalent circuit. And similarly, you have to then look into the circuit through BC and find out the Thevenin equivalent circuit. So once you have the Thevenin equivalent circuit, you can also find out the Norton's equivalent circuit. So find the Thevenin's and Norton's equivalent circuit. So you can do this. This is your problem for today.